Welcome to the world of online learning. I am Dr. G.K. Viju, Professor, University of Garden City, Khartoum, Sudan. We at GK Online Learning Tutorial emphasize on the topics from software engineering, project management, quality management, strategic management, and mathematics. Today we are going to discuss the topics from software engineering. Please subscribe to our channel for continuous support. The next topic is requirement analysis and specification. Before we start to develop our software, it becomes quite essential for us to understand and document the exact requirement of the customer. Experienced members of the development team carry out this job. They are called as system analysts. Or in other words, requirements analysis focuses on the tasks that determine the need or conditions to meet the new and altered project or product, taking account to the possibility of conflicting requirements of the various stakeholders, analyzing, documenting, validating and managing software or system requirements. Or requirement analysis is critical to the success or failure of a system or software project. The requirement should be documented, actionable, measurable, testable, traceable, related to identified business needs or opportunities, and defined to a level of detail sufficient for system design. The following basic questions pertaining to the project should be clearly understood by the analyst in order to obtain a good grasp of the problem. Question number 1, what is the problem? Why it is important to solve the problem? What are the possible solutions to the problem? What exactly are the data input to the system and what exactly are the data output by the system? What are the likely complexities that might arise when solving the problem? If there are external software or hardware with which the developed software has to interface, then what exactly would be the data interchange formats with the system B? SRS document. Software Requirement Specification or SRS is a document created by system analyst after the requirements are collected from various stakeholders. It is a responsibility of the system analyst to document the requirements in technical language so that they can be comprehended and useful by the software development team. So in SRS document, generally it contains functional requirements of the system, non-functional requirements of the systems, and goals of implementation. What are the functional requirements? Or functional requirements define a system or its component. It describes the function a software must perform. A function is nothing but inputs, its behavior, and outputs. Functional software requirements help you to capture the intended behavior of the system. And then comes non-functional requirements. They are the requirements that specify criteria that can be used to judge the operation of the system rather than specific behavior. They are contrasted with the functional requirements that define specific behavior or function. In other words, a functional requirement describes what a software system should do, while non-functional requirements place constraints on how the system will do. Let me elaborate. An example of the functional requirements would be a system should send an email whenever a certain condition is met. That is, for example, an order is placed, a customer sign up, etc. Its related non-functional requirements of the system may be email should be sent with the latency of no greater than 12 hours from such an activity. So, by these examples, the functional requirement is describing the behavior of the system as it related to the system's functionality, whereas that of the non-functional requirements elaborate the performance characteristics of the system. Typical non-functional requirements are accessibility, capacity, current and forecast, compliance, documentation, disaster discovery, efficiency, effectiveness, extensibility, fault tolerance, interoperability, maintainability, privacy, portability, quality, reliability, resilience, response time, robustness, scalability, security, stability, supportability, testability, etc. Decision tree. A decision tree gives a graphical view of the processing logic involved in decision making and the corresponding actions taken. The edges of a decision tree represents conditions and the leaf nodes represents the actions to be performed depend on the outcome of testing the condition. In other words, a decision tree is a decision support tool that uses a tree-like model of decisions and their possible consequences, including chance, event outcomes, resource cost, and utility. It is one way to display an algorithm that only contains conditional control statements. So here they had given an example. Consider the library membership automation software where it should support the following three options, that is new member, renewal, and cancel the membership. So here it has been given for new member, renewal, cancellation, and invalid option. There are two conditions, yes conditions as well as no condition. Then comes decision table. A decision table is used to represent the complex processing logic in a tabular or a matrix form. The upper rows of the table specifies the variables or conditions to be evaluated. The lower rows of the table specifies the actions to be taken when the corresponding conditions are satisfied. A column in the table is called a rule, and a rule implies that if a condition is true, then the corresponding actions is to be executed. Or in other words, decision table are the concise visual representation for specifying which actions to perform depends on the given conditions. They are algorithms whose output is a set of actions. See here an example for the same. So we have conditions and we have its corresponding. We have conditions and we have actions for the corresponding conditions like valid selection, new member, renewal, cancellation, no, yes or no questions, display the error message, ask members details, build customer records, general bills, etc. etc. Formal system specification. A formal technique is a mathematical method to specify a hardware or software system. Verify whether a specification is realizable, verify that an implementation satisfies the specification, prove properties of a system without necessarily running the system, etc. And the mathematical basis of the formal methods is provided by the specification language. Or in other words, a formal software specification is a specification expressed in a language whose vocabulary, syntax, and semantics are formally defined. In the 1980s, many software engineering researchers proposed that using formal development method was the best way to improve software quality. In computer science, formal specifications are mathematically based techniques whose purpose are to help with the implementation of systems and software. So here they had given an example. Specify the pre and post conditions of a function that takes a real number as argument and returns half the input value if the input is less than or equal to 100, or else return double the value. That is f of x equal to real, and real precondition x belongs to R, post condition x less than or equal to 100 and fx equal to x by 2, or x greater than 0 and fx equal to 2 star x. Software design. Software design is a process to transform users' requirements into some suitable form which helps the programmer in software coding and implementation. For assessing user requirements, an SRS, that is Software Requirement Specification document, is created, whereas for coding and implementation. Software design is a process by which an agent creates a specification of a software artifact intended to accomplish goals using a set of primitive components and subject to constraints. Software design usually involves problem solving and planning a software solution. Software design yields three levels of results. Architectural designs. It is the highest abstract version of the system. It identifies the software as a system with many components interacting with each other. At this level, the designers get the idea of a proposed solution domain. Second one, high-level design. The high-level design breaks the single entity, multiple component concept of architectural design into less abstracted view of subsystems and modules and depicts their interaction with each other. And detailed design, it deals with the implementation part of what is seen as a system and its subsystems in the previous two designs. It is more detailed towards modules and their implementations. It defines logical structure of each module and their interfaces to communicate with other modules. So that is architectural design, abstract version of the system, high-level design, subsystems and modules, detailed design, implementation part. Modularization. Modularization is a technique to divide the software system into multiple discrete and independent modules which are expected to be capable of carrying out tasks independently. Coupling and cohesion. Cohesion is the measures that define the degree of interdependability within elements of a module. The greater the cohesion, the better the problem design or program design. Coupling is a measure that defines the level of interdependency or interdependability among modules of the program. The lower the coupling, the better the program. Or in other words, we can tell cohesion, grouping of all functional related elements, whereas set of coupling, communication between different modules. So here, a diagram for high coupling and low coupling. See here, this is for high coupling and this is for low coupling. This is the end of the session. Please like, subscribe and share. If you are having any queries, please mail to me to the mail ID given here. Thank you.